how do we calculate this area of a surface? So suppose you have a 3D object and you're interested in calculating the area of that object. This is basically the double Riemann sum of the magnitude of the cross product of RU, RV, delta U, delta V. So you're basically creating some small rectangles on the surface. You're using some small tangent planes, and then add them all together to find this area of the surface. So this is the idea behind it. If a smooth parametric surface like S is given by the equation R of U and V, these two are your parameters, and it's denoted by X of U and V in the direction of x-axis plus Y of U and V in the direction of y-axis plus Z of U and V in the direction of z-axis, with the condition that U and V, these two new parameters, belong to domain D, and S is covered just once as U and V ranges throughout the parameter domain D, then you can calculate the surface area of S with the following formula. A of S is the double integral over domain D of the norm of the cross product between the derivative of R with respect to U and the derivative of R with respect to V, dA. RU is the partial derivative of X with respect to U in the direction of x-axis plus partial derivative of Y with respect to U in the direction of y-axis plus, as you guessed, the partial derivative of Z with respect to U in the direction of z-axis. We can also calculate R of V, which is the partial derivative of X with respect to V in the direction of x-axis plus partial derivative of Y with respect to V in the direction of y-axis plus partial derivative of Z with respect to V in the direction of z-axis. So you have two vectors. You need to find the cross product between these two vectors and then find the magnitude or norm. If you have Z as a function of X and Y, then the surface area or area of the surface also can be calculated as the double integral of the square root of 1 plus partial derivative of Z with respect to X to the second power plus partial derivative of Z with respect to Y to the second power and dA. So in this question, we are interested in finding the area of the part of paraboloid Z, which is x squared plus y squared, that lies under the plane Z equals to 9. Since Z is written in terms of x and y, and it's a nice formula, to find this surface area, we are using A, which is equal to the double integral of the square root of 1 plus partial derivative of Z with respect to x to the second plus partial derivative of Z with respect to y to the second power dA. This in turn is equal to the double integral of square root of 1 plus partial derivative of Z with respect to x, as you can see, is 2x to the second power plus partial derivative of Z with respect to y, which is 2y to the second dA. Now, if you simplify this, you get the double integral of the square root of 1 plus 4x squared plus y squared dA. This is the object that you're looking at. Z is equal to x squared plus y squared, and Z is equal to 9, which is basically stopping your surface at this area. If you look at the projection in xy plane, as you can see, you have a disk. Well, in this case, you can write A or the area of the surface as the definite integral of square root of 1 plus 4r squared r dr, and r as the radius ranges between 0 to 3, and as you guessed, pi, the theta is bounded between 0 and 2 pi. You can use u sub. This is the integral of 0 to 2 pi of d theta times the integral of r square root of 1 plus 4r squared dr. The very first integral, the integral of d theta, theta ranges between 0 to 2 pi, is 2 pi. And then to calculate the second integral, we use u sub. U is equal to 1 plus 4r squared. Du is 8r dr. So as you can see, you end up with 1 over 8. And then you have 1 plus 4r squared, 2 power 3 halves times 2/3. Then you plug in 3, then plug in 0, and do the subtraction. So the area of the surface is pi over 6, 37 square root of 37 minus 1. And to do the calculation, you can also use a calculator to get an approximation.